the next step is to write all the elevations in the second line of this table here. You see 54 meters as the elevation of cross section A at centerline projection, so 54, and also I need to calculate the next elevation of the next cross section number 1, 2, 3, etc., with the names of the cross sections here. So the first cross section is at 54 meters, point A. Cross section number 1, just one after A. In order to calculate that, we go back to the plan drawing. Okay, so this is my cross section A, and the elevation is 54, 60, 58, 56, 54. Now I need to calculate or interpolate the elevation of this point on cross section 1. It's basic mathematics, really. You need to measure the distance from the center line of that cross section to the next contour line in one direction and read it, in my case, 10.65. Also measure the total distance from one contour line to the next contour line, and that is 26.73 meters. Okay, I have already prepared a drawing for you to be able to see clearly. This is 10.65 and another 16.8 meters from this point to that point. Okay, and this is the 54 meter elevation contour line. This is another contour line, 56, and this is the point that I am looking for, and this is my center line. It looks like a triangle. Okay, here you can see 54 meters, 56 meters, 10.65 meters the distance from 56 meters to the center line, and 16 meters or 8 the distance from the center line to the next lower contour line. Altogether, the total distance between the two contour lines is 26.73 meters. So the ratio is that if I go 26.73 meters in total and change 2 meters elevation, what would be the elevation change or height difference if I go only 16.08 meters? Okay, you calculate something out of that, plus 54 meters is the elevation of the lower contour line. So that gives me 55.20 meters as the elevation of this red dot here, which is my center line in the profile view. So the elevation of that is obviously definitely between 54 and 56, and it is 55.20 meters. If this, let's assume, if this cross section, if this center line would have been exactly in the middle between this point and that point, obviously the elevation of that would be exactly 55 meters. If it is closer to the higher elevation contour line, it is more than 55 meters. If it is closer to the lower elevation contour line, it is less than 55 meters. So it's just basic ratio of this right angle triangle. So therefore 55.20 is the elevation of this red line. 55. Now I'm going to type in this 55.20 into my profile drawing. 55.20. Okay, what you can do is you can copy this, paste it, and then type in 55.20. That's it. And you have to repeat everything for every cross section. Don't forget to also write the cross section, that is number 1. Okay, and that's it. So you have to repeat this for every cross section using the same similarities of triangles, and starting from A to the last cross section B, together with the names and the distances between them. So I have updated my table, my profile drawing table. Here we have the horizontal scale, vertical scale, those lines, horizontal lines, my datum 53 meters, and the cross-section names A1, 2, 3, H1, 4, 5, 6, H2, 7, 8, etc. The elevations calculated one by one for each cross-section, 55.20, you remember from the previous calculation. The distance between each cross-sections, 25 meters, etc. And obviously, if there are special cross-sections, then you have different distances. From 13 to TC, only 18 meters, 1832. And after TC, because it's a horizontal curve, for every 10 meters we have cross-sections, and we have special cross-section H5. Therefore, here we have a different distance. M, special cross-section, different distance, etc. So you already know that. The 25, 50, 75 meters, again 0, 25, 50, 75, 0, 25, 50, 75 distances. Hectometers 1, 2, 3, 4, 5. Kilometers 0. So for example, for this cross section number 10, you read 0 kilometer, 3 hectometers, 300 meters, and 25 meters, 325 meters, things like that. Also at the bottom here, you need to provide horizontal alignment information. So the whole drawing is a profile drawing, but the last line here gives us information about the horizontal alignment, not vertical alignment, horizontal alignment. The only way of doing it is to indicate the direction of the curve with some curve additional information written on it. For example, in my project, let's go back to the plan view again. Starting from A, which is on my left hand side, going to the B, which is on my right hand side, I look from left to right in the direction of increasing stations. So from A to B, I have an anti-clockwise rotating horizontal curve in the bird's eye view. So my curve is turning to the left. The center of my curve is on my left hand side as I look towards my project in the direction of the increasing stations. So therefore, in the profile drawing here, you provide that piece of information by showing this step line. So because I am turning left, I have step downward, indicating that in the direction of the increasing stations there is a left turning horizontal curve. This distance here is the straight alignment until the curve, okay, and here there is another straight distance, 128, is after the curve. These are all from the plan drawing, and these are the same as the curve properties that you have on the plan drawing as well: the radius of the curve, the deflection angle, the length of the curve, the external distance, and the semitangent distance. Okay, so you have to complete the table, the profile drawing table, everything except the first line, which is in red color at the moment. Okay, so you have to complete this, all elements of this table except the first line at this stage.